This is the video for the categorizing numbers, fractions, order of operations homework video. So the first thing we're going to look at is identifying numbers. First thing we want to find with the first set of numbers is integers, and those are whole numbers. They can be positive or negative, and we have negative 1 and 3, the first two numbers, so those are highlighted. Next thing we want to look at is rational numbers. Those are whole numbers, fractions, or decimals that can be turned into fractions. So we have negative and 1, 3. We still want to have those highlighted because those are still rational numbers. We want to add 3.7 because 0.7 can be changed to 7 over 10, so that can be rational. And then we have 1/7, and then at the end we have 9/10. Those are fractions, we have whole numbers, and we have a value with a decimal that can be changed into a fraction. So those are all rational numbers. Next, let's look at irrational numbers. Those are decimals that go on forever. So anything with pi, and then if you see the ... at the end of decimals, that's going to be irrational. So we have 4.7281 ... and then 6 pi. Okay. Lastly, let's look at real numbers. Those are rational numbers and irrational numbers. So in this case, you should have everything highlighted. Negative 1, 3, 3.7, 1/7, and 9 over 10 are rational, which falls under real numbers. And then 4.7281 ... and 6 pi are irrational, which also falls under real numbers. So all are real numbers. Okay, let's look at when a list says between some numbers. When it says between, don't include the numbers given. So in this case, negative 3 and 4. You're just going to write anything that falls in between those two, kind of like it says. So negative 2, negative 1, 0, 1, 2, and 3. Now, if it says greater or equal to and less than or equal to, you do include the numbers given. So in this case, 6 and 10. So we're going to have 6, 7, 8, 9, and 10. Okay, let's look at when we look at opposites, reciprocals, and absolute values. With an opposite, you change the sign of the first number. So that column that says number right there, that's your go-to number. You'll always go back to that number for the reciprocal, for the absolute value, for the opposite. That's your number. Okay, reciprocals, you're going to flip the fraction, and again, you're going back to that first number on the left, and you're flipping that fraction. And then lastly, the absolute value is the positive of the original number because it's the distance away from 0. So on our first one, our opposite is 17. So we need to change the sign to get back to our original number. So we have negative 17. Now I put it over 1 because if you have a whole number as your number, then you need to put it over 1 so that we can flip it for the reciprocal. So the reciprocal is 1 over 17. And then one thing that I left out here that I need to add is a negative sign, because you keep the sign of the actual or the original number. Since our number is negative 17, our reciprocal also needs a negative. And then the absolute value is the positive of our original number. Our original number is negative 17, so our absolute value is 17. Okay, so for our reciprocal, we have negative 7 over 6. Our number has the same sign as the reciprocal, so that's why there's a negative, and then you just flip that fraction. So the bottom becomes the top, and the top becomes the bottom. So we end up with 6 over 7. For the opposite, we go back to our original number, so negative 6/7, and we just change the sign. So that's how we got 6 over 7. We just took away that negative. And then our absolute value is the positive of our original number. So negative 6/7 turns to 6/7. Lastly, we have negative 13 So since there's that negative that I have circled, the opposite would be positive 13. Our reciprocal keeps that sign of a negative, and you just flip it. Anytime you have a whole number, you're going to put it over 1, and the reciprocal will be 1 over that number we have. So reciprocal is negative 1 over 13. And then our absolute value is the positive of our original number. We had negative 13, so our absolute value is 13. If we had 4 as our number, our absolute value would also be 4. That is not going to be a negative 4 in the absolute value. Always, always positive. Okay, addition and subtraction with fractions. With addition and subtraction, you have to have the same bottom number or bottom denominator. You cannot add these fractions together as is. So to get a common denominator, we're going to multiply the two bottom ones together. So we have 8 times 5, which gives us 40. So we're going to have something over 40 plus something over 40. We are not going to keep negative 7 and 3. We have to change our numerators. So to change our first one, we multiply negative 7 and 5. And that's going to be on our new first spot. So up there I have negative 7 times 5. And then for our second one, we cross multiply the other two. So 8 times 3. From there I can have negative 7 times 5 is negative 35. 3 times 8 is 24, so I have negative 35 over 40 plus 24 over 40. Now that I have the same denominator, 40 and 40, we can add the top numbers together. You keep the denominator the same, so your answer is going to be over 40. So negative 35 plus 24, we get negative 19 over 40. For subtraction, we're just doing the same thing, but instead of adding, we're going to subtract. So we need to get that common base first. So we have something over 20 minus something over 20. Cross multiply to get our new numerators. Our first one's going to be 1 times 5. Our second one's going to be 4 times 6. So we have 5 minus 20 minus, or 5 over 20 minus 24 over 20. So 5 minus 24, we get negative 19 over 20. For division, we need to flip the second fraction and then multiply the numerators together and multiply the denominators together. With multiplication and division, there's no cross multiplying. It's all top row, bottom row. So we have negative 9 over 10, then we need to flip that. So we have negative 5 over 1, multiply the tops together, multiply the bottoms. Negative 9 times negative 5 is 45. 10 times 1 is 10, so you get the answer of 45 over 10. Multiplication, you don't have to worry about flipping a fraction. Just multiply straight across the top, straight across the bottom. So we have negative 5 times 2 divided by 6 times 3, which gives us negative 10 over 18. Okay, order of operations. So for this top left one, we have values in the parentheses that doesn't have a variable, so we need to solve inside those parentheses first. So 1 minus 3 is negative 2. So then when we rewrite it out, we have 3 times negative 2 to the third. The next step in order of operations is exponent. So we need to do that next. Since the exponent is odd, the value inside of the parentheses, since it's negative, it's going to stay negative. So we have negative 2 times negative 2 times negative 2. Because remember, the exponent tells you how many times you're multiplying that base number by itself. So we have negative 8. From there, we can then multiply it by the 3. So we have 3 times negative 8, which equals negative 24. Okay, for the second one, the one furthest on the right, it also has parentheses, and there's no variables inside there, so we need to solve that first. So negative 5 minus negative 3 divided by 8, you get negative 8 over negative 8, which gives us negative 1. Next, we need to do the exponent Again, since it's odd and we have a negative number, the value is going to stay negative. So we have -1 times -1 times -1, which ends with -1. Okay, so on our last one, the bottom left, we have a variable inside our parentheses, so we can't solve in there first. We need to solve for that x value. So what we're going to do is distribute that 4 on the outside of the parentheses, which means we have to multiply both the variable in 3 by 4 and the -1, just not the x variable. So we have 4 times 3x minus 4 times 1. So we get 12x minus 4 equals 6. From there, we want to get the x by itself and have the numbers on the other side. So we're going to do the opposite of subtracting since we have minus 4. So we're going to add 4 to both sides to cancel with the 4 on the left. So we end up with 12x equals 10. Then we divide by 12 to get x by itself. So our value is x equals 10 over 12. Okay, writing the expression, the first thing we want to do is identify what different properties we're working with. We have the difference of y and 3 amounts to 12. So difference goes with subtraction, amounts is equal. So we're going to do y minus 3 equals 12. So you just go down the line. That and is kind of where you put whatever math symbol you need to put. Okay, let's look at the second one. Twice goes with multiplication, plus is addition, and same as is the equal. So twice x would be 2x plus 5 equals -14. Our third one says 3 more than would be addition. The product of 4 and c, product is multiplication, is 7. And is that equal? So we're going to have 3 plus 4c, because 4c is the same as saying 4 times c, equals 7. Okay, this last one's a little confusing, and I'll kind of explain why. So the quotient is division, and then is equal, and then more than is 3. Here's what it's saying. The quotient of 8 and y is 3 more than y. So you know you're going to have 8 divided by y, because with quotient the top value is on top, or the value before and is on top, the value after and is bottom. So you're going to have 8 over y, but then you're going to have plus 3 equals y, even though 3 is on the other side of the equal sign in the wording. The reason why is it says it is 3 more than y. So y by itself on that equal sign, we need something that's 3 more than that on the other side, because it says that this quotient is 3 more than that. And that's why the addition's on that side. I hope this helps. Good luck on the rest of the homework. Let me know if you have any questions.